right, so these questions can get really difficult because it's a lot of really annoying fraction stuff that you don't remember how to deal with fractions, essentially. Hopefully you're getting practice back. So I'm going to rewrite 15a as 1 on A, take 1 on B. Now the easiest way when you've got fractions is to cross multiply. And what I mean by that is you've got 1 times B over, minus 1 times A over the bottoms times together, A times B. So I'm going to color code where I'm getting my numbers from. So this one is this one. This A, here, here. This one, this minus is this minus. This one is this one. And this B is this B. So do you see where I'm getting those from? So it's top times the bottom of the other side minus the top times the bottom of the other side over the bottoms multiplied together. This gives us 1 times B is B minus 1 times A is A over A times B is AB. Every second, isn't it? Yep. Okay, so C is a bit harder. We've got x to the minus 2 take y to the minus 2 to the negative 1. And it's going to be easier if we deal with what's inside first. So this is the same as 1 on x squared take 1 on y squared to the minus 1. Once again, we're going to cross multiply. So we're going to end up with y squared minus x squared over the bottoms multiplied together, x squared, y squared. Now there's nothing else for it. We're fine on the inside of that bracket, so now let's get rid of the negative indice on the outside by flipping it upside down. X squared, y squared over y squared take x squared. And now it's to the positive 1, but we don't bother. And finally, question E. I'm probably going to regret giving myself this little room. So we've got x squared. Well, I'm going to rewrite this as 1 on x squared, y squared. Well, because it's 1 on x squared times 1 on y squared. So why have them as separate fractions when they're multiplied? Let's put them together. X squared, y squared. There we go. Times, now this is x squared on y minus y squared on x. I'm going to deal with what's inside the brackets and then I'm going to multiply by the outside. I'm going to do this by cross multiplying. So on the outside we've got 1 on x squared, y squared still. On the inside we've got x squared times x, x cubed, minus y squared times y, y cubed, over the bottoms multiplied together, x, y. And now they'd like us to put it all together, which means it's the same as 1 on x squared, y squared times x cubed take y cubed on xy, yeah? Because it's times, we can just put the bottoms together straight away. So I'm going to rewrite this as times. And what happens is, we can just go, well, that's 1 times x cubed take y cubed. And this is x squared, y squared times x, 1y1. So this is the same as x cubed take y cubed over x cubed times y cubed. Huh. Do you notice the pattern between those three questions? You should. question 16. Explain why 12 to the n is the same as, okay. Now, I'm going to do that quickly up above. 12 to the n is the same as 4 times 3 to the n, which is the same as 2 squared times 3 to the n, which is the same as 2 to the 2 times n, 3 to the 3 times n, so it's 2 to the 2n times 3 to the n. Using similar methods, write these expressions with prime bases and simplify them. Now, again, we're doing every second question. So, let's have a look at A. 2 to the n is already a prime base. 4 is the same as 2 squared to the n. 8 is the same as 2 cubed to the n. So this is 2 to the n times 2 to the 2 times n, 2n. 2 to the 3 times n, 3n. So we've got n plus 2n plus 3n, 6n. Question C. Now this is, I'm going to write it as a fraction. 6 to the x times, 6 is the same as 3 times 2 to the x times, now 4 is the same as 2 squared to the x over 3 to the x. So this is the same as, I know I should do below, 3 to the x times 2 to the x times 2 to the 2x over 3 to the x. See what's going to cancel out? And we're left with 2 to the x plus 2x, which is 2 to the 3x. Finally, E. It looks hard, but it's not. Now, 100 is the same as 4 times 25, yeah? 25 is the same as 5 squared. 8 is the same as 2 cubed. The problem here, 4 is the same as 2 squared. 25 is the same as 5 squared. Now I can work. So that's 2 to the 2 times 2 and take 1 times 5 to the 2 times 2 and take 1 times 5, 2 times minus 1, negative 2, times 2, 3 times minus 1, negative 3. Okay, this is the same as 2 to the 4 and take 2, 5 to the 4 and take 2, 5 to the minus 2, 2 to the minus 3. Okay. This one's a 2 and this one's a 2. So we've got 2 to the 4 and take 2, take 3. This one's a 5, this one's a 5. 5 to the 4 and take 2. Oh, so that when I said take 3, that's plus minus 3. Plus negative 2. Okay, so we've got 2 to the 4 and take 5. 5 to the 4 and take 4. That's it. Next question. Yeah, okay, I'll write it down here. So if we've got, I'll do this in green, 3 to the n plus 3 to the n plus 1, then that's the same as 3 to the n plus 3 to the n times 3 to the 1, isn't it? Which means I've got 3 to the n appearing in both terms. This is 3 to the n times 1. So I've got 3 to the n. In the first term I had 1. In the second term I had just 3 to the 1. Which means it's 3 to the n, 1 plus 3 to the 1. Well, it's 1 plus 3, it's 4. We're going to do something similar with all these questions. So for A, we've got 7 to the n plus 2 plus 7 to the n. And I'm going to take 7 to the n out the front. So I'm left with 7 to the, I'm just left with the 2. And I'm left with essentially nothing. Every time I'm left with nothing, I do a 1. So when I say plus 2, that's that one going there. Because this one appears out the front. Every time you've got nothing left, you write plus 1, because you're dividing it. 7 to the n divided by 7 to the n is 7 to the 0, so it's 1. Okay, so that's 7 to the n outside of 49 plus 1, 50. So that's 50 times 7 to the n. Okay, I'm doing every second one of these. 5 to the n minus 5 to the n, take 3. So this time, what we're taking out the front, 5 to the n. So we've got 5 to the n outside of 1 minus 5 to the minus 3. So that's 5 to the n, 1 minus 1 on 125. So it's 124 on 125 times 5 to the n. I'm assuming that's what they want. Doesn't look very simple. Okay. And E. I've got 2 to the 2n plus 2 minus 2 to the 2n, take 1. I'm going to take 2 to the 2n out of each of these. And I'm left with 2 to the 2n, 2 to the 2 minus 2 to the negative 1. 2 to the 2n, 4 minus 1 on 2. So that's 2 to the 2n. 4 minus a half is 3.5, which is 7 on 2. So that's 7 on 2 times 2 to the 2n. This is just a really good skill to learn for later on when we come to do some actually really complicated questions. Maybe I should have asked you to do every one of those. Oh well. Too late. Okay, so we're going to use a mixture of methods to do these. So, I'm going to rewrite this top one. I'm going to rewrite that 6 as 2 times 3. And this 2, I'm going to rewrite it as 2 to the 1. Okay. So this is the same as 2 to the n times 3 to the n plus 3 to the n. And this is the same as 2 to the 1 plus n plus 2 to the 1. You're going to see why I did that shortly. What's common in the top line? 3 to the n. So I've got 3 to the n outside of 2 to the n plus 1. And on the bottom line, what's common? 2 to the 1. 2 to the 1 outside of 2 to the n plus 1. See what gets cancelled out? These. So this comes out as the same as 3 to the n over 2 to the 1, which is 2. That's pretty cool. I like it when they do something like that. Okay, question C. Alright, I definitely want my primes. So 12 is the same as 3 times 2 squared to the n minus 18 is the same as 3 squared times 2 to the n over 3 to the n minus 2 to the n. So this is the same as 3 to the n times 2 to the 2n minus 3 to the 2n times 2 to the n. Now, you're probably wondering, how can I take something out of this? Well, it's going to be easier if we rewrite 2n as n plus n. This is just a funky trick. And this is why it's worth doing heaps of these kinds of practice problems, because this is kind of question that could come up in an exam, be a band 5, band 6 kind of question. Now what goes into both of these? 3 to the n does, 2 to the n does, which means I can take both of them out. 3 to the n times 2 to the n. On the first term, I'm still left with 1 times 2 to the n. And in the second term, I'm left with 3 to the n times 1. See what's about to happen? I've got 3 to the n minus 2 to the n. So here I've got 3 to the n times 2 to the n times 2 to the n minus 3 to the n, which you may be thinking that's upside down, that's the opposite way around with the minus from what we want. We know how to deal with that. We've learned how to deal with that. Which means we've got 3 to the n times 2 to the n times negative 2 to the n, take negative 3 to the n. So 3 to the n, take 2 to the n, equals. So here we've got 3 to the n times 2 to the n times negative 3 to the n, take 2 to the n. So you didn't need to do this line of working out. If you remember that, you just chuck a negative out the front and turn it around. Because now you can see, we can get rid of these. So this becomes negative 3 to the n times 2 to the n. I don't know if the answer wants it as negative 6 to the n, but that's fine. I probably wouldn't. And that's simplified. That whole thing came down to that. That's pretty cool.